Hello everyone, this is Liwei. In the lecture we studied superposition for AC phasor circuit. So in our lecture we have example 2 of superposition. So let me explain it here in this video. So it is corresponding to example 2 of our lecture, superposition. So let's look at the circuit. We have voltage source. So the voltage source is 10 times sine t minus 30 degree. So we have a resistor 1 ohm. So it is connected to a capacitor of 1/6 farad, and we have another resistor 2 ohm. So it is connected to a DC voltage source minus plus 24 volt. So here we have a current source. So it is a AC current source. So 2 times cosine 3t. So we have a 2 Henry inductor and connected to resistor 4 ohm. So basically this example is the same example in the lecture notes, but in the course I didn't have time to cover it. So I want to cover it in the video. So in this circuit, what we want us to solve is I/O, so output current. So I/O, so because we have 3 independent sources, so we can use superposition. So I/O will have 3 components. So it I/O can be equal to I1 plus I2 plus I3. So these 3 current are corresponding to 3 different sources applied separately. So let's see, how do we determine I/O? So the first step here is to find I1. So I1 is due to 24 volt source. So suppose we only apply 24 volt DC source and we turn off the 10 sine t minus 30 degree voltage source, and also we turn off 2 times cosine 3t current source. So we only apply the 24 volt DC source. So let's look at the circuit topology. So for voltage source, so if we turn off voltage source, that means the voltage source will be 0, and that means we short circuit the voltage source. So for the left hand side, the voltage source, we short circuited. And then we have a resistor which is 1 ohm. So we have a capacitor which is 1/6 farad, and then later on I can convert it into impedance based on the frequency of the circuit. But we can note that if we apply just the 24 volt DC source, so this capacitor will be open circuit for DC in steady state. But let me have it here for now. So here we only apply 24 volt. So here we have 2 ohm. And so we had a current source in this position. So we need to turn off the 2 times cosine 3t current source. So for current source, if we want to turn it off, that means current will be 0. That means the current source will be open circuit. So here for the current source here, it is open circuit. So here we have, this is 2 Henry. So here is 2 Henry. So we have here 4 ohm resistor. So we are looking at the current I1 due to 24 volt DC source. Okay, so this is the circuit when we just apply 24 volt DC source. So as I mentioned, so because it is a DC circuit, so in steady state, so the capacitor will be equivalent to open circuit in DC, while the inductor will be like a short circuit. In DC. Yeah, because it's a DC circuit. In steady state, capacitor is blocking the DC current, and the inductor is a short because it's a DC circuit. The current is a DC current flowing through the inductor, and the induced voltage is 0. So it is a short circuit. So we can short the inductor and open the capacitor. So now in this condition, so what is I1? So this is easy. So I1 is equal to, so here we have 24 volt applied. So 24 volt applied here in this loop, it generates a current. So the current will be 24 volt divided by 6 ohm. It gives us 4 amp. Okay, so we finished step 1. So in step 2, so we want to find out I2. So I2 is the current due to AC voltage source only. So that means, so we only apply the AC voltage source, and we turn off the DC voltage source and the AC current source. So let's draw the circuit topology. So we apply the AC voltage source. So for the AC voltage source, so it has amplitude of 10, phase angle of minus 30 degree, and the base function is a sine function. So the frequency is 1. So this is very important. So the frequency is 1. So the amplitude is 10, and the phase angle is minus 30, and it's a sine function based. So we have also a 1 ohm resistor. So minus J6. So here I need to decide the impedance of the capacitor. So the impedance of the capacitor, first let's look at the capacitance of the capacitor. It is 1/6 farad, and then later on I calculate the impedance based on the frequency. So we have another component. So this is 2 ohm resistor. So here, so let's look at the circuit. So here, so if we turn off the DC voltage source, it will be a short circuit. That means, so the DC voltage source is a short circuit. And then we have the AC current source. We should turn off the AC current source according to superposition. So when we turn off the AC current source, so the current is 0, it is open circuit, like step 1. So it is open circuit. Okay, so we have 2 Henry in series with 4 ohm. So we will decide the 2 Henry impedance later based on the frequency of the sources, of the source, sorry. So here is 2 Henry, and here is 4 ohm. So here is output current. due to AC voltage source. I call it I2. Okay, so for this circuit, how do we solve it? So first, we have to convert the capacitor. We have to calculate the capacitor impedance. So 1/6 farad. So the corresponding impedance is 1/j omega c. So it is 1/j times omega is 1, c is 1/6. So we have 6 times minus j, because 1/j is minus j ohm. So the impedance of the capacitor is minus j6. So let's look at the inductor, the impedance of the inductor. So for 2 Henry inductor, the impedance is j omega L. So because omega is 1, so L is 2 Henry, so we have J2 ohm. So now, let's write the impedance for the inductor. It is J2 ohm. So now we have the circuit topology. So how do we solve the I2 current? So here we can use mesh analysis. So let's define mesh current. So we have 2 meshes. So let's define this current is the so-called mesh 1 current I1. So let's define this current is the so-called mesh 2 current I2. So you see here, this I2 current actually is corresponding to I2 in time domain. Okay, so let's write the 2 equations based on KVL to solve for I1 and I2. Okay, so let's first write the KVL for mesh 1. So the first term, when we write mesh analysis, the first equation, so this is based on mesh 1. The first term is the sum of total impedance in mesh 1. The sum of the total impedance gives us 1 plus 2 ohm minus J6 ohm. So this is the total impedance times mesh 1 current. So this is the voltage drop in mesh 1 due to I1. So the second term is minus the sum of impedance in common to mesh 1 and mesh 2. So the impedance in common to mesh 1 and mesh 2 is 2 ohm. So times I2. So this is the voltage drop due to mesh 2 current. The voltage drop in mesh 1 due to mesh 2 current. Okay, so let's look at, we have independent source in mesh 1. So the current, the loop current I1 flow into the negative terminal of the independent source. Based on KVL, so it has a minus sign, so minus 10 minus 30 degree is equal to 0. Okay, so this is equation 1. So let's look at equation 2. So for mesh 2, so we can write, so the first term is the voltage drop due to I2 current. So here in the bracket, it should be the sum of the total impedance in mesh 2. So we see here, so the sum of total impedance is, so we have 2 ohm here. So we have here 2 ohm. So 2 ohm plus 4J 2 ohm plus 4 ohm. So this is total impedance in mesh 2. So minus the sum of the impedance in common to mesh 1 and mesh 2. So the impedance in common to mesh 1 and mesh 2 is 2 ohm. So times I1. So this term is corresponding voltage in mesh 2 due to mesh 1 current. So because we don't have any sources in mesh 2, so we can write, so it is equal to 0 directly. So this is equation 2. Okay, so let's manipulate these two equations into matrix form. So we have, so here we have 3 minus j6, and here we have minus 2, so we have I1 and I2. So it is equal to, so we move minus 10, angle here is minus 30 degree to the right hand side. So we have 10 angle minus 30 degree. So this is for equation 1. For equation 2, so we have minus 2 here, and we have 2 ohm plus 4 ohm, so it is 6 ohm plus J2. And so here the right hand side is 0 because there's no source. Okay, so now we can solve it easily. So we can solve for I2. So I2 is the phasor, the current phasor is 0.504, 19.1 degree. So I2 current, so let's write I2 current in time domain. So the amplitude is 0.504, because the base function is a sine function. The base function is a sine function. So it is sine function here. So the frequency here, the frequency is 1. So it is t plus 19.1 degree. Okay, so this is the current, output current I2 due to the AC voltage source. So let's look at step 3. So in step 3, so we need to find I3 due to the AC current source. At the same time, we turn off the AC voltage source and the DC voltage source. So I3 current is the current due to the current source, and we turn off the voltage source, DC voltage source, and the AC voltage source. Okay, so let's write the circuit topology. Okay, so we turn off the AC source, which means we make AC source short circuit, and here we have 1 ohm, and here we have 1/6 farad capacitor, and later on we calculate the impedance based on the frequency of the AC current source. And here we have 2 ohm resistor, and here we have the DC voltage source, which is turned off. That means it's a short circuit. And here we have current source. So the current source here is 2 times cosine 3t. So the amplitude is 2, phase angle is 0, frequency is 3. It's cosine function based. So it is 2, phase angle 0, so the frequency is 3, so it is cosine function based. So here we have the inductor, so the inductance is 2 Henry. So later on we need to calculate the impedance, but for now let's put 2 Henry here. And we have the resistance here, 4 ohm, and the output current I3 is here due to the AC current source. Okay, so now we have the circuit topology, so we want to calculate I3. So first, let's convert 1/6 farad. Let's calculate the corresponding impedance of the capacitor. So it is equal to 1/j omega c. It is equal to 1/j, omega is 3, c is 1/6. So it is 2 times minus j ohm. So minus j is because 1/j is equal to minus j. So the 2 Henry inductor, the corresponding impedance is j omega L, so which is j times 3 times L. L is 2 Henry, so give us j6 ohm. So now we can write the impedance in the circuit. So it's j6 ohm. So here, for the impedance of the capacitor, it is minus 2j. So we can see, so for this AC circuit, for this AC phasor circuit, so we only have one AC current source, and our goal here is to find out I3, or first we find out the phasor current I3, and then we can convert it back to the time domain to calculate the time domain current I3. So first, how do we calculate I3? So let's look at this branch, so the left hand side branch. So we can combine, so you see here this branch is in parallel with this branch. So first we can calculate the total impedance of this paralleling branch, these two paralleling branches. So that means, so this 2 ohm is in parallel with 1 minus 2j, or j2 ohm. So the total paralleling impedance is equal to a fraction. So the numerator here is 2 times 1 minus j2. The denominator here is equal to 2 plus 1 minus j2. So we should know how to calculate the total impedance of a paralleling branch. So this is very important. So we can further simplify it. So it is 2 minus j4 over 3 minus j2. Okay, so now we can redraw the circuit. So we assume, now we have a total equivalent impedance for the paralleling branches, and then we have the current source, and then we have j6 ohm impedance for the inductor, and we have here 4 ohm resistor, and we want to find out this branch current I3. So the current source here is 0 degree. Okay, so how do we calculate I3? So we can use current divider. So current divider is a very convenient tool to calculate a current in the paralleling branch if we know the total current. So current divider tells us, so the total current, if the total current here, it is 2 times 0 degree. So if I want to calculate the current flowing into one branch, which is 4 ohm plus j6 ohm. So first, if I look at, I have a fraction here. So if I look at the numerator, so the numerator will be the impedance at the other branch. That means, so the impedance at this branch. So the impedance of this branch is 2 minus j4 J4 over 3 minus J2. So it is 2 minus J4 over 3 minus J2. So the denominator will be the sum of the impedances in the two paralleling branches. So it will be 2 minus J4 over 3 minus J2 plus the impedance in another branch plus 4 ohm. Okay. So we can solve for the final solution. So it is 0.3352 minus 76.43 degree. So if we convert it into time domain solution, so we can take the amplitude, which is 0.3352 times cosine function, because the base function is a cosine function, times omega t. So omega is 3, so we have 3t plus the phase angle. The phase angle is minus 76.43 degree. So this is our time domain solution. So because we know I1, so we calculated I1, so which is 4 amp, and we calculated I2, and we calculated I3. So we can combine three currents. So the total current I0 is equal to I1 plus I2 plus I3. So which give us the final solution. Okay, thank you so much for watching the video. If you have any question, please let me know. Thank you. Bye bye.